Okay. Hello everybody. My name is Kate Forbes and I am Education and Operations Manager for Passivhaus Trust. It's my privilege today to welcome you to the second session of the Passivhaus Client Clubs. And we have a number of people joining us for the first time today. So I'll start with a quick explanation of how the session is going to run. We are aiming to create a support network to upskill our professional and technical workforce and enable growth in the number of passive house projects so that we can share best practice and reduce the risk of the performance gap or of inflated costs or reputational damage to clients. So today's session, Sarah will be setting the scene on cost optimization in passive house. So she'll be doing a short presentation for us first. And thereafter, we have three amazing advisors who are joining us today, who we've also invited to do short presentations. Thereafter, we'll have a 45-minute breakout room conversation for more informal discussion. And depending on the number of people that end up attending today, we will try and keep them into manageable size groups so that everybody is heard in those conversations. And then we'll pull back into the main room. We'll have a quick summary of the session, and the recordings of the presentations will be available on our website. So, for the moment, you can turn your cameras off. You can relax for the next half hour. There's no need to speak. And we will start today with a presentation from Sarah Lewis on the scene setting of cost optimization. If you've not met Sarah, she is our Research, Policy and Education Director at the Passivhaus Trust. She's an experienced architect, having delivered both Passivhaus and Enerfit projects. She is the author of the book PHPP Illustrated, which is a user guide to using the Passivhaus planning package, and she's also a trainer for co-action. I could keep going, but I will stop there and let her introduce cost optimization session today.
Thanks so much, Kate, and thank you everybody for joining us. It's really great to see many of you joining us live during the session today, and welcome also to people who are catching up on the recording after this session as well. Okay, so I only have, I'm trying to see if I can, there we go. I only have 8 minutes in which to do this presentation, so I'm going to whiz through really quickly, but there'll be opportunities in the breakout session to go into all of these topics in more detail. And hopefully what I'm doing also is probably introducing what's going to be coming up with the next three speakers as well. So I thought I'd start with this quote by Wolfgang Feist, who was the founder of the Passive House Standard, saying that investing in value instead of energy consumption requires little financial efforts, but rather creativity and intelligent solutions. So sorry about the quality on this slide. It's not come across very well. But this is just to say that in terms of having a cost-effective passive house project, there are a few things that we can do as design teams very early on in the project. And one is really paying attention to the form of our building and getting our consultants to do that. So we refer to something as the heat loss form factor, which is just the external envelope of our building divided by the floor area. And it gives us a really good indication of how efficient that building form is. So you have smaller buildings, which will always have a higher form factor, and the bigger buildings are always going to have a lower form factor. And then interestingly, if you take the form factor number and multiply it by 100, it pretty much gives you how many millimeters of insulation your building is going to need for, say, a passive house in a mid-UK location. So there's obviously variations here, but it's just to highlight that at the very large passive house scale, you might be down to as little as 70 mil of insulation, while for the buildings that have the worst form factor, so your bungalows and things, you might be needing as much as 450 mil insulation. So it's not that there's a universal amount of insulation that we need to add to all passive house buildings over building regs. In fact, some might even need a little bit less than the notional building in building regulations. So it's just something to be very mindful of, that those decisions around the form of our building have a direct impact on the cost of those projects to deliver. But it's not just about form, it is also about complexity. So these are just a couple of images that I pulled off the internet just for like typical new build buildings. So there's a domestic house and and a high-rise block. And a lot of the cost and complexity of a project can be a bit hidden from the form factor number. So it wouldn't turn up in the form factor, but if you have things like projecting balconies, big parapets, maybe complexity in the foundation and the ground because of the ground conditions, all these things can add significantly to the project cost and the risk of delivering the quality we need for Passive House. So we have to be very mindful of that. And there's other things which are maybe even harder to see from a client perspective when it comes to complexity. So things like the position of the MVHR unit. If we get that right, the installation and quality of the installation can be very easy to deliver in practice. If the MVHR unit is in a suboptimal position in the middle of the plan or something, we've got a long way to insulate ducts, to work out ceiling hanging joist, the duct. Totally lost the word, but anyway, the duct supports that we would need, all of that adds to the complexity of the project, and not just the efficiency of the MVHR, but actually the success of the project from a quality point of view as well. Whereas where we have really successful Passive House projects that kind of optimize the form factor by having a very rationalized form, and also move a lot of the complexities that we might see visually, like the balconies and things, to the external side of the building, we're able to deliver very cost-effective Passive House solutions. So it's that form factor and complexity brought together to deliver a cost-effective solution. And we're able to do this by following these kind of Passive House principles, these 8 principles of Passive House. So there's the 3 core principles of approach to create this integrated approach to delivering Passive House. The first is the very specific performance and comfort criteria, which we know if we deliver it, the building will be able to perform. We model our buildings in a very accurate tool, the PHPP, which allows us to know that we can meet those performance criteria and comfort criteria critically for the occupants. And that helps us to do that in the most cost-effective way if done well with an experienced consultant team. And then we have the quality assurance, and this is one of the sort of great badges that Passive House is able to bring to a project, that whole piece around quality assurance. On top of that, we have the kind of the 5 building principles. So this is what everyone's always very familiar with. And often these are the only principles which are referred to. And these are things which are already covered in building regulations, but the Passive House standards set specific performance criteria for these things. So windows, the insulation, to making sure we've got a continuity to that insulation, air tightness, making sure we've got a very clear air tightness line. Thermal bridges have to be very carefully understood, modeled, minimized to deliver a cost-effective Passive House solution. And then we need that balanced ventilation in the UK. But just having those 5 things alone without those principles of approach won't deliver a Passive House building in practice. If you want to just refer to an easy digestible guide covering those key principles of Passive House, I put up a QR code on the screen there, and that's just an image of the Passive House Trust Passive House Principles primer. So what does claiming the Passive House really mean? So it means that those first 3 principles of approach have been followed in addition to those kind of normal, often referred to 5 building principles. And any building could be made into a Passive House with enough effort, with enough money, and with enough time. However, the purpose of the session today is really saying that what we want are resource efficient buildings, delivering optimum value for clients, and therefore the designs need to be optimized. And certifiers are really an expert in this field and can provide optimization support throughout your project. So what is in a name? What's in the Passive House name? So if someone claims a building is a Passive House, they're really claiming that it meets the standard strict energy, comfort, and quality requirements. So phrases that we hear a lot, like Passive House Light, following Passive House principles, inspired by Passive House, they're not defined phrases, they're not defined statements, and are likely to be misleading, giving a false impression that a project in question is going to actually perform like a Passive House without meeting those key performance criteria and comfort criteria that you would expect. And the worst that can happen, we've got a paper called Misunderstanding Passive House Principles. And again, there's a link up on the slide there. So the kinds of costs clients have faced after completion for these Passive House Light projects, so ones that aren't actually Passive House projects. So cost of discomfort to occupants, higher energy costs than predicted, there's a cost of rectification up on the screen there. That was £16,000 per unit, so per home, to rectify those buildings to get back to the Passive House standard. Reputational cost, higher build costs, a lack of accountability, which is a real issue on these projects. So Passivhaus certification is this independent, impartial service, with the certifier very much representing the best interests of the building owners now and into the future. And it provides you with that kind of golden thread of input through the design and construction process. And for our clients, it means that you're going to be catching mistakes early while they can still be remediated. The benefits you get from the certifier's experience, which is across a really wide range of projects. And then you'll also have confidence that for all those materials and things that you're paying for to go into that building will result in the performance you expect. So I just wanted to spend, I think I'm at my limit, but I just want to spend the last minute just running through where we are with some of the costing work from the Passive House Trust. So back in 2015, we had a Passive House capital cost research project, and that resulted in our 2015 paper. In 2019, we updated that. So we've got a new capital cost project paper, and that's a QR code to link to that paper. And we produced this primer the following year just to pull out some of that key information that we were getting from that cost work. Since then, Passive House projects have significantly increased in scale in the UK. And this was the last time we published a cost paper, so 2019. And since then, we can see that actually the Passive House numbers have doubled, more than doubled, in terms of the scale of Passive House delivery in the UK. And in that primer we published in 2020, you could see that what we were showing was that the current cost uplift for Passive House in 2019 was about 8%. And we were seeing that falling over time and projecting into the future that we would see 4% extra costs once Passive House was adopted at scale. So at this point, what we are looking to do at the Trust is commission some new work. So last year we worked with a number of our social housing clients in Scotland, some of whom are on the call today. And we produced a paper looking at some of their early projects and where some optimization could be found. I presented a little bit of that work at the last session, and Phil, who completed that work, is with us again today, and our Scottish client. So if you want to hear more about that, we can maybe do that in the breakout session. And then earlier this year, we published a paper looking at the cost uplift of the Future Home Standard compared to Passive House. So that's available on our website. And then coming soon, we're just about to produce a short briefing note on retrofit costs for 2025, looking at the Passive House Enerfit standard. And we've also got the Passive House new build capital cost update. So that will be coming probably towards the end of this year. So do look out for that. And that will be showing whether or not we're getting closer to that 4% uplift. And then this is a quick news flash from the 19th of May. Joel's with us today, who will be expanding on this. But we were all very excited at the Trust when we heard that Barratt plans to build all of its flats in London to the Passive House standard and hopes to roll that out to all social housing in the capital. So exciting stuff coming. And I think on that note, I'm going to hand over to Phil Lewis, who'll be talking through some of the work with Exeter City Council.
Good afternoon. Thank you, Sarah. So the journey began um, in 2015 for Exeter, and yet there's an image there that shows a number of the projects that have been carried out. The very first one, Knight's Place, top left, was an apartment block, and talking about form factor, you can see what was envisaged there. The middle top is there were a number of garage sites where actually we provided sort of 3, 4, 5 units on each garage site using terrace construction. Um, Top right was Chester Long Court, which is 21 apartments for the elderly. Uh, and then they got bold and they did some Sidwell's Point, which is well, 4 swimming pools, a gymnasium, and lots of other bits that's quite well known. Middle bottom is Edwards Court, which is an extra care scheme. and the one on the bottom right is Hammond Gardens. So that's another 20 odd unit apartment build. So Exeter has been on a journey. There are more schemes than this, but it gives an impression, it shows what type of scheme that we have provided. And why did it happen in Exeter? I think is the key question. Well, first and foremost, it was based around the city council, and it was client driven, and it was really the chief executive down. Everyone bought into, yeah, we're going to do this. We're going to have Passive House. There was a development company provided, and it pushed on with building to Passive House standard as its default. Okay. And this was not just based on viability, but they took into account other benefits as well. And so it was a more rounded business case, not just on the cash. It was on comfort, it was requirements, fuel poverty, etc. And it took into account um, a larger mandate from the council. And the third bit that allowed them to do it is they had the land. The opportunity was there. There was council owned land which they could build on. So they have probably done 8, 9, 10 projects between 2015 and 2025. The latest one you can see in construction there, which is 36 apartments, all passive house on a site that will eventually provide 90 units. So what's been the impact of that sort of leadership, if you like? Well, if you go to the southwest, you have an awful lot of your chain already trained in passive house. They know how to deliver, and that's really important. And that's what happens when you get when you get engagement all the way through. You have consultants who are aware of passive house, who know how to design for it, who have done the training courses, and are in competition with each other to come up with methodologies and ways of performing, and others adopt. So the top right picture, that's from Plymouth Community Homes, which is a housing association not too far away. Bottom right is the new multi-faith centre at the University of Exeter, which is Passive House. The University of basically, this part of their sustainability guide require all their buildings now to be built to Passive House. So it's grown with the council. Just quickly on some of the things that we've learnt, and part of it's timing. So most of their builds have been monolithic construction, quite often using clay block. Uh, but the reason for that is they started in 2015 and timber frames weren't really an option at that time. The retooling, etc., was too much. Now that's changing, which is why I've put the word timing in there. And you need to actually consider much more using your PHPP at an early stage with your QS to work out your most optimal um, design for your area. Um, we know that terracing is good form for housing. We know it fits quite well with garage sites, etc. We've also learnt that you need to keep the M&E simple. Um, don't over-engineer it. Decentralized systems. Trust your PHPP. You don't need to include a full wet rad system to your buildings for heating. You just don't need it. Um, those buildings that we've delivered often just have one electric panel for heating, and that's it. That's all they really require, and even that doesn't get used. So, and be mindful that regulation changes impact passive house. So we still need to meet the requirements of SAP. We still need to, to meet the different parts of the building regulations. Sometimes they're not necessary because you're delivering to passive house, but you have to build them anyway, often for a good reasons. But just be mindful that when you're comparing costs and optimizing costs, you can't, we could be far more cost effective if we could get regulations to take into account PHPB more. Okay, and this slide, I'm using this slide only because it's from a previous cost seminar we did. But I just wanted to point out that actually optimize all your costs, because your passive house element is particularly, it's not a vast amount. It's about 10% of your overall project cost. So to get a good scheme that works well, then do review all of your cost elements, including your external works, etc., because they will have probably a bigger impact than the passive house costs in terms of gaining efficiencies. And a few observations. I'll be very quick. So timber frames are getting there. Okay, there's a few frames now in the market, and there's a bit more competition. Um, but I think that it takes market dominance. Same with MEP systems. We want air source heat pumps, for instance, which are smaller than you would require for a building regs type home. Remember, specification drives price. So if you're specifying expensive goods, it's going to be an expensive building. You just need to work with your QSs to do that as much as you can. Um, Simple design, cheaper to build, repeatability at scale is where you're going to save money if you can. Okay, and a few observations. Often other costs are lumped in with passive house costs. They're not necessarily. You just need to be very mindful of what you're designing and split it properly. Um, and always be aware of risk pricing and additional prelims. It's happens less once the market is aware of what you're trying to do and how to do it. So in the Southwest, you'll see risk pricing has reduced for these types of builds compared to where we were 5, 6, 7 years ago. Because once your supply chain has understood it, then the risk pricing will be more realistic. Okay, I will pass on.
Thank you, Phil. That is really helpful to hear. I didn't introduce Phil at the beginning. I know Sarah had kind of handed over there. Phil is from Randall Simmons, and as you can tell, has huge amounts of experience in delivering Passive House. I think the QS project manager angle is really interesting to hear, and the supply chain adapts, I suppose, is the biggest takeaway personally from what you're saying there. Going to hand over now to Jay Cotterill, who is an experienced architect and consultant in energy efficiency and net zero housing. They have delivered and developed the PH15 construction solution, which uses off-site technology and low embodied carbon materials to build self-build and affordable housing. And she's also the co-author of the Passive House Handbook. I'll hand over right now to Jay.
Thank you very much, Kate. I'm going to dive straight in because of the limitation on time. So we've heard some interesting factors already in those last two talks, but we really, for cost optimization, which I'm extremely interested in, we have to avoid complexity, of course. And then with passive house, taking the passive house route towards low carbon housing, then we need to extract the social value. And by extracting the social value, I mean all the co-benefits, and for me especially the significant health benefits that come along with the passive house indoor air quality. And then there's also the lower maintenance and replacement burdens that are possible with the passive house route to low carbon housing in terms of services, which has also been touched on, which I think is important for housing associations and councils to be picking up on. And it's not always what you're going to get, but you need to keep your eye on it, and passive house certainly enables that to happen. And it's all about this, what it cost uplift is sustainable, 5 to 10%. Yes, I think we can probably say it's sustainable, but if it starts to elevate much beyond that, where affordability is key for our choices, we start to have a bit of a problem. And this is an interesting thing that happens with passive house projects, where this is a project here with some data around some passive house flats that were built. And you can see they've got a very good form factor, in fact, so a very efficient shape. Sarah explained what form factor is earlier. But if you actually investigate and dig away into the PHPP, the modelling software, you can see that one of the key criteria, which is heat load, is very, very low on this project. And that means there was a capacity for optimization that the PHPP is highlighted, but actually in the performance criteria, it's not actually been realised. And then to look at like one or two of the details of that, you can see here's one of the details from the designers. And what they're trying to do here is to reduce the thermal bridge, where there's a very weak point where windows join walls, and they've really gone to town with it. And they're over insulating the frame inside and out. There's lots of layers going on, and they will have got a very good site value for that detail, but it's very much a one-off detail. And if you can compare it to something like this, which is a much simpler, where more has been stripped away, what I'm sort of highlighting here, that really we need minimal performance within the Passivhaus criteria, and we want to think about sufficiency in our detailing and in our approach, and we want to protect those co-benefits, just sufficient to protect those co-benefits. And the Passivhaus designer, the person who's really experienced with the use of PHPP, that managing the risk of over design is an integral part of their job description and should be seen as such. And I'll just give you one more detail here, again, where the designers are really doing a good job at dealing with the thermal bridge. It's a very difficult junction between wall and floor. So you can see here they're putting in a lot of PIR insulation here, the yellow, and then they've got a lot of foam glass here as well in block form and slab form. And that's quite an expensive product. And what they're doing is trying to make sure they've got continuity across the junction, which they're doing. They've probably got, again, quite a good SI value, but actually was it needed for Passivhaus certification? The answer is no, and probably you could have got rid of that, and probably you could have done something different with that element there. So there's lots of optimization that can happen once you start looking at sufficiency, rather than thinking of Passivhaus as some sort of like excessive perfection thing. And of course, pattern books can really help on details. This is a book by someone called Emma Walshaw. I think in the book there's about 8 different construction methods with about a dozen pages on each, to showing the sort of details one might. It's sort of helpful to look at, but it is difficult because we live in a culture with so many ways of constructing houses, and that makes it difficult to simplify. Because we can't all be experts on everything, and actually good simple details emerge over use with time, so that repeating is necessary to sort of build up, and our focus needs to be on that, and never to forget that PHPP gives us an extra gift, and that extra gift is the dynamic aspect for cost optimization beyond just the detail. And in my professional life, I definitely work on the basis of this pattern book approach. You know, there's a detail there, a photo of what it looks like in a building, in a social housing project, and then the SciCalc associated with that. And we would, over the years, been building up many of these details that we can just reference. And I think councils in the past would have had that sort of approach when they used to build housings, but unfortunately, a lot of that's been lost, and we need to now build that sort of catalogue up ourselves anew with a carbon agenda. So big house builders are a good model to look at because they're really good at cost optimizing, and they do it through standard detailing, and they also have standard house types, of course, as well, and they have workforces and specification chains very specifically orientated, and then they repeat and refine. The weakness is that generally the main focus is on private profit, and has been in the past, not some of the other things that as councils and social housing providers we want to be interested in delivering and achieving. So it's a balance between all these things. But you know, certainly if you look at the successful big house builders, they do not, you know, give their professional team a free license to design whatever they want and build in any construction method and create unique details and learn on one-off ad hoc bases. And you know, sometimes you can get an exemplar scheme, but it's going to be, the cost is going to be elevated, and really we just want repeatable, ordinary housing being built to this standard and being able to be replicated easily. That's where we want to get to for the number of houses that we want to be seen being built. I think a good model is the Victorians. A better model, they had a standard material palette and construction details, and they had also the layout type, the terrace, and we see that across the UK. And the building force knew, they knew how to do a bay, they knew how to do a porch, they knew how to do a chimney, and it was very cost effective, and they achieved quality, longevity, variety in design. Unfortunately, they're not energy efficient, and the indoor quality is dodgy and are certainly not thermally comfortable. But there is certainly space, I think, within this idea of cost optimization for affordability in social housing for that sort of pattern book approach in detail and in plan and house type. And really with this thing to deliver the co-benefits for me. And here's a council who's been going along these lines. So this is a 1-bed, 2-bed unit, quite a nice plan, sort of signed off. But there's much here that's not really covered, that's to do with low carbon housing. So I can point out a few things like the MVHR sort of shows a sort of lack of understanding maybe about Passivhaus MVHR. It's sort of indicating a reliance on air source heat pumps. The construction is sort of suggesting, or are we just building as building regs construction? We've not really thought too much about that. We haven't done any energy modelling. We don't know what the overheating risk is. There's a lot in there. We don't have any accurate prediction of performance, energy performance, and will the co-benefits be protected or will they get lost? So we can then start to elevate that, and here same design being elevated up to Passivhaus level, MVHR being addressed in a more robust way, an option being provided on the left that doesn't have any heat pumps associated with it at all, so really minimising the M&E. The construction, the width of the construction being targeted at a particular approach that has an airtight strategy associated with it, and then the modelling alongside it for PHPP and for SAP. So we know we can start to build up again information about exactly what we're going to be providing and what our cost profile is going to look like. And then you can see that the two sort of sides of the coin that we work with in this country. So the SAP is indicating for this particular council location, you're getting A-rated 98 in a semi-detached format. And then on the Passivhaus side, you'll see that it's being allowed to be a low energy building. So we're thinking pragmatically, that's all it needs to be. It's a very small house type. So we're not becoming the victim of perfection. We're just looking at how we can get where we need to get using the Passivhaus methodology. So if I want to summarise that very quickly, I think the strategy, there's a lot to be said for this strategy. And I'm focusing really on the amount of housing that we're wanting to achieve. So the focusing on a construction method, maybe a single one. If you're a big organisation, it may need to be more than just a single. Standard, simple details, being very conscious about the choice of the construction method, always using PHPP as an optimisation tool and being very pragmatic. And then, looking at pattern book house types that are Passivhaus led and for affordability purposes. And then protect delivery of co-benefits. Thank you.
Thank you, Jay. That's absolutely fantastic, really clear and really interesting angle. We're going to quickly move over to Joe Callow. Joe is the director of Beyond Carbon and with 16 years experience in the construction industry, a specialist in daylight and facade optimization. He's got a range of experience, which I'm sure he'll share with you, and we're tight on time, so I will stop there and hand over to Joe.
Thank you very much, everybody. Really great to be here, and really found those first talks fascinating, and they dovetail beautifully with what I'm about to say as well. So I hope you'll find that the next few minutes are adding to what you've heard already and heading you in a helpful direction. So my talk is particularly about high density housing development. So we're talking about London, and we're talking about generally 4 stories and above, but it doesn't have to be London. But we're talking about housing typologies that are not semi and terraced, but have gone beyond that towards apartments, in effect, high density housing. So I'm going to very quickly bust 5 passive house myths. I'm going to do these in 1 minute per myth, so you should not expect an enormously thorough debunking, but a brief overview of some things that people say about passive house or mistakenly believe about it. And then I'm going to quickly give you some examples of what we've been doing in London on high density multi-resi and how we managed to drive costs down for Barratt, who got mentioned earlier on in the meeting. So without further ado, number 1, too expensive. Now, we kind of covered this already, but I'll just briefly give you our view on this. You've seen already the data from the earlier Passive House Trust documents, and Sarah's told you about some stuff that's coming up this year as well. We would not be working with Barratt Homes to deliver all of their London projects to a certified Passive House. They will be certified if it was costing them 4% extra on their standard build cost. So I wouldn't give away Barratt's commercial confidential information, but it really is very, very cost effective. And our general review of cost of apartment delivery in London is that it could be cost neutral or even lower cost than the equivalent London plan compliant apartments. Now, I realise that's a niche. London is its own unique market, but I think the lessons we've learned there would apply more broadly as well. So I think we at Beyond Carbon are confident that overcost on high density housing can be zero if optimizations are ruthless. And you've heard a fair bit already, Jay, and others have talked about this. You've really got to zone right down to the tiniest details and leave no stone unturned in search of standardized, simple delivery, particularly the MEP design, again, as has already been mentioned. Okay, that was surely around a minute for the first one. Number 2, it's just too hard to do passive house. We should do something easier. Is a common myth. We disagree with that one very profoundly. We work on passive house every day. We work on all sorts of scales of projects with a huge variety of clients. And we find that actually the industry at large is getting increasingly hungry and enthusiastic for better quality and are willing to upskill in passive house. So that's not just the main contractors. It's not just the client end who are procuring this. It's right down through the supply chain as well, which is a critical part of all of this. So we work a lot with contractors and supply chain, upskilling and training. And what we generally get is a real enthusiasm for better, which is something that I think has really changed in the last few years. So I'm encouraged by the industry hasn't got there yet, but it wants to, and it's moving fast. So we believe passive house is challenging, and it ought to be because it's a very high quality standard, but it's eminently deliverable by the UK construction industry. Number 3, not needed. Well, I mean, I gather we're all in the room to discover why it is needed, but I thought I'd just cover this anyway. Why is passive house needed? Why can't we just do better using a business as usual or improved business as usual approach? I mean, there's a long story here, but the short one, and the long story, by the way, you can see in the links there, which will be shared afterwards, among other places. The short answer is we're not delivering on operational energy, and that means our residents' bills are higher than they should have been, and we are not correctly delivering high performance buildings. So you sometimes hear in the industry, oh, we've got operational energy all sorted out. It's all about whole life carbon and upfront embodied carbon now. I don't disagree that those things are important, but the idea that we've sorted operational energy, I'm afraid, is not true. And we need to, because we need our residents to have low bills. We need that to be part of a low carbon infrastructure, national infrastructure of zero carbon in the near future. And we can't do that if all our new residential buildings consume much more energy than we all thought they were going to. Secondly, and possibly even more importantly, climate resilience. So anything we build from now on and anything we retrofit from now on should be with the lens of how resilient will it be to our present and our changing future climate, particularly heat waves. And so our view is that passive house is urgently needed to resolve this. Which beautifully segues me into my number 4 myth, which is that passive houses overheat, don't they? Is that right? No, unfortunately, for the myth, the opposite is true. Passive house buildings, well designed, particularly where they have taken care with their solar shading, and we would do that on every project ourselves, they are actually far easier to prevent to overheat than building regulations buildings because of their tight building envelope, careful window design, and MVHR systems. We have some specific things we do in London, which I can talk about perhaps in the Q&A afterwards, which are particularly tuned towards climate resilience and overheating prevention. Our view is that passive house is essential, really, for addressing overheating. Far from being a problem, it is a solution to that issue. And finally, number 5, airtightness. So we do get a lot of comments. Well, it's a very challenging standard, Joel. Are you really sure? 0.6 air changes or 0.6 permeability in a larger building. Wow, we don't normally deliver anything like that. That's 5 times better than we normally deliver. And it turns out when you drill down, that people are achieving air tightnesses of roughly 5 times Passivhaus by not trying at all. So 0 effort gets you a 3, and some effort gets you a 0.6. And what we would say is that there's a huge amount of emerging innovation in the air tightness arena, a couple of which I put on screen there just for reference. And our view now is that air tightness, far from being a risk to contractors and a risk to projects, is actually an opportunity. If you look at the ways in which buildings can become more comfortable, lower energy and lower running costs, so lower bills, air tightness is one of the easy wins, not one of the hard wins. The other ways to do it are generally more expensive, require more materials, and bring greater upfront or embodied carbon to the project. So we would swap this around and say, no, air tightness isn't a risk, it's an opportunity to get very low cost improvements to your building if you do it right. And much of what's been said already today about standardized detailing, care with simplicity rather than over designing, we would totally agree with. We regularly get brought onto projects at stage 4 and the detail is already over designed and we are value engineering it back to just complying with Passivhaus from over complying, where people have just spent lots of extra unnecessary money on details they didn't need to have and products they didn't need to have. So we design to the Passivhaus standard, not beyond it, because it's so good. Why would you do any better than it? Right, that's the myths busted, hopefully. It might take me a couple of minutes more than 5. So I'll now push through what are we doing in London, why is it cost effective, and can it be something we learn from elsewhere in the UK as well? So like Sarah earlier, we also have 3 core issues that we're addressing in our multi-resi design work for high density housing. And you can see them in the circle there. So this is simplified MEP is the bottom right, EAHP. I'll come on to that in a moment. Improved fabric specification and window optimization. Let's look at those 3 quickly in turn, starting with improved fabric. So on high density multi-resi, so our 4-story and above apartment schemes, we're finding that the U values that the building regs require are already beyond what's actually sensible and cost effective for performance delivery. You would actually like higher U values than Part L pushes you towards, or certainly the London Plan does, if you were actually optimizing for cost. In other words, they recommend, say, 0.16 walls. In fact, you should put a 0.2 wall in and spend the extra money you've saved on windows, airtightness, and thermal bridges. So it's gone beyond what's actually sensible to do. Now, we can't actually do that because Part L requires those values in some cases on some projects. So in the end, Part L determines the U value for the wall, and Passivhaus would gladly have dealt with it in a much more sensible way were it allowed to do so. So we focus on airtightness, windows, and thermal bridges in our fabric improvements, and then the quality of the fabric is critical as well. So it's not just what you put on paper, it's what gets built, and particularly thermal continuity. And I could say more about that, but not for today. Next one. EAHP is exhaust air heat pump. It's this clever box you can see on the right here. This is a decentralized non-air source heat pump solution, so it doesn't have an external box outside the building. In the case of apartments, that's really vital because you don't want a load of boxes strapped to the outside of your building. This box does those 4 things on screen: heating, cooling, hot water, and the MVHR, certified Passivhaus MVHR, all in a single box, single point of control, single maintenance regime, filter changes and so on as usual. And it decentralizes, you disconnect from any kind of notion of a community scale or district scale heating solution. That drives down cost, it drives down embodied carbon quite dramatically compared to business as usual, and it brings with it the benefit of a very small amount of Passivhaus compliant space cooling, so peak lop cooling for heat waves as well. Number 3, window optimization. This is my personal favorite. As it was mentioned, my passion over many years has been facade optimization, which means getting windows in particular, but also building orientation exactly right. So we're not aiming for, roughly 90% right. We're saying, no, 100% optimal. No stone left unturned. Every window in a building sized and positioned and reveal depth and frame size and frame thickness and opening type optimized for overheating, daylight, and solar gains. Minimal solar gains in the summer, maximal solar gains in the winter. It's really hard. All those things fight against each other. They want different things from the windows, but actually there is a place in the middle of the bullseye, that is optimal, and that's where the lowest costs reside. So with any luck, this is going to rotate. Yes, it did. That's great news. So digital twin, fancy word, just means really good building modeling. We would suggest that PHPP has to be the root of the operational energy model, but you need some other stuff as well to do complex buildings. You need overshadowing, you need solar mapping, to name just a couple, and you need overheating analysis at the same time as you do the other stuff as well. So digital twins allow all of that to take place at the same time inside software systems that are designed for that. We have one of those ourselves, and it means you can optimize for Passivhaus, daylight, and overheating on these complex projects at the same time and get through the middle of that bullseye for least construction cost and best outcomes in the end. Okay, what comes out of all of that is thousands of iterations and possibilities, and you then pick the winners together as a team. That's where the cost consultant would be critical to that process, as would the Passivhaus designer. And what you're finding is the line of the 1,134 options that your computer has spat out at you, you're finding the line through all of that that is the lowest cost way of achieving Passivhaus. You do not over comply with Passivhaus. If you get 6 watts per square meter heat load, you've got an over-designed, overly expensive Passivhaus building. 9.5 at the tail end of the project, that's good news. That means you designed it to the standard and you didn't waste any money. So just to finish off then, very briefly, the Barratt stuff that's going on, you've seen a picture of this already. We're all pretty excited about this. This is Bollow Lane. It's nearly 800 apartment units. It's all done on the basis of what I've just shown you. So decentralized heat, optimized fabric, optimized windows. And Barratt are planning to roll out what they're calling their low E approach, which is certified Passivhaus in London, on every London project. So they're going to be building something like 1,500 dwellings per year and larger numbers in London, certified to Passivhaus. From this point onwards, Bollow is just the first of those. And it's a really exciting step change for the industry, really. And we're finding that others are rapidly asking, well, how are they doing it? Why is it cost effective? And can we do something similar, please? And the answer is yes, please do. If you're building high density, Passivhaus is game-changingly good for everything. I think I'll probably just close out really by saying outside of London, we're finding a lot of Passivhaus interest as well. What you're seeing on screen there is a student residential project, which is, I think, currently the largest certified building in the UK, but I believe it's about to be knocked off its top spot by other projects. And that is Herdown View in, near Bristol for the University of West of England. And there's loads of other stuff. We reckon there's more than 1 million square meters of Passivhaus buildings in progress at the present time that we're aware of or involved in. Ourselves, let alone all the rest of the industry as well. So it's really gone big and it's gone fast. I think that's me done. Then my slide, yeah, there we go. That's the closing slide. So I shall close out there and hand back to
That's
us team.
absolutely amazing, Joe. Thank you so much. What a combined set of interesting presentations, and hope that helps fuel the discussion. Okay, guys, if you're able to, you can turn your cameras back on when you get to your breakout rooms. We are going to have 2 breakout rooms. Breakout room number 1 will have Sarah and Phil, and Jay and Joe will be breakout room number 2. Feel free to ask any questions of them, or your key question to discuss in the room, explaining, sharing your Passivhaus journey to date with a focus on cost optimization or the challenges that you've had in that area. Possibly start with your positive experiences, but feel free to progress on to the challenges. We split the rooms this time into 2 breakout rooms. There's about 10 to 12 in each, if everyone stays. And we have made sure that there's a range of experience in each room, but this time we haven't split them by geography. So do feel free to feed back to us if that works or that doesn't for you. And we've got just over half an hour, 35 minutes before we get, and we will give you a 5-minute warning before that room closes. Cool. So Lynn, if you're able, can you push everybody into the breakout rooms, and we will see you in there. Everyone, welcome back to the main room. We're nearly done with today's session, but before we go, it would be really useful if we could get a little bit of a summary of what was discussed in each of the rooms. Sarah, I know you were collating that summary just before in room 1. Can you give us a wee bit of an overview of the conversation, please?
Yeah, absolutely. So we had a bit of a geographical divide. So we were seeing quite a different argument being had with the kind of London client side and high-rise London specifically to basically the rest of the UK, which just has quite a different financial model to be dealing with, where we have lower rise buildings, higher fabric costs, therefore lower value for the end product, especially when we go into some areas where there's a significant reduction in property values. So I think basically that came across in the conversation. I think the key thing for us taking forward from our group was very much that the financial argument is not yet clear and it's not yet won, and there is some more work that needs to be done around looking at linking. And it wasn't so much about actually the exact numerical value of how much extra a passive house costs over a standard build. At this point, it was to do with the wider value that the passive house buildings are able to deliver, and if we can put more monetary numbers against that. So even where there is a cost uplift because you're in a part of the country where property values are lower, there's still all these co-benefits that were being discussed in the presentations earlier in the session. And if we can put some money towards those to help people create a kind of robust argument to go back to their councils or the people that are actually making the decisions on what is built. Does that feel good, everybody in the room? I'm looking for some nodding heads. I think we got, yeah, cool.
Thanks, Sarah. Jay, Joe, anything to highlight from the conversation in your room?
I think we had a little bit of discussion at the end about the complexity of M&E solutions and how many options there are on the markets, and looking for really simple solutions and the challenge of that. And then the client groups finding it difficult to have the influence maybe they would like to have over what's going on with the designs and the detail and the technical side of things. We sort of noted how much investment has probably gone into Barratt's to get to where they are with their solution. How much work probably goes into optimizing, and they've got a lot of technical expertise that they can call on and control that in-house before they roll anything out, and other people doing it like councils and developers and stuff not having quite that resource, but that can be shared. So a desire to see that information all being shared out so that people can optimize, and then just the level of interest in people want to, you get a sense people really want to, a couple of people from Wales really wanting to do the stuff, and how can they make that happen and achieve the optimization that is needed if it is going to happen, because it's not going to happen unless that optimization is in place. I think that's covered most things. Joel might have something to add.
No, that was a great summary, Jay. Thank you. Yeah.
Right. Thank you so much for your time today, everybody. There's a few things that I would like to share with you before we leave. And yeah, so some of you may be already, but if you're not a Passive House Trust member, please have a look at the membership page of our website. It does outline both promotional and educational benefits that the membership offers and might be of interest. We also have a Passive House social page, which is focused on social housing, and we've collected together all of the relevant information, including presenter videos from these sessions. So if you've missed anything or if there's anything you'd like to revisit, they are available there. And the most exciting thing I think that I am able to share with you is we have created a new Passive House social housing LinkedIn group. This is an invitation only group, so it will only be the client group from these meetings, but the ambition being to keep the conversation going and to aid that kind of informal connection and peer-to-peer network support. I know that there's a couple of let's get in touch moments from the conversations that I overheard, and that would be brilliant if we can help facilitate making that contact a bit easier. So please note the link there. We have our Passive House conference in Ireland this year in Belfast. It's on the 7th and 8th of October, and there are a number of public sector clients with successfully delivered projects that might be of interest to you. So if you haven't noted that already, that is up and coming. Only thing left to say is thank you for attending the session today. We'll use the conversation to guide the content of our future sessions. So please do feed back to us if you've got any further thoughts on how we can help support you and develop this journey. If you've got a particular challenge that we would be of benefit and you require a dedicated specialist support, email us directly and we can see if we can link you up with the right specialist to help support your project. Thank you, Joel, Jay, Phil, Sarah, for your genius today. And I did see also a number of other speakers from our previous session. And today, thank you for joining us again and your continued sharing of expertise. Our next session is on Tuesday, the 16th of September at the same time of 12 o'clock, and we hope to see you then. Thanks, guys.